Muted. Muted.
Good evening, everyone. Can you all hear me? Am I audible? Please confirm before we proceed. And are you all able to see my screen? Yeah, thanks, Jason. Thanks, Shanti. Yeah, okay. So let's get started. So till now we covered some basics of basic classes and interfaces that are related to collection framework. Okay. So maps also is under the collection only, but they are not actually collections. Okay, because maps don't extend collection interface. Okay, we'll start this session with maps. So most of the important classes that are related to collection framework are we have covered in our previous session. So we will try to cover maps and the rest of the things in today's session. And one more session I would need for the util package. So because there are few more classes which needs to be covered. Once that is done, we will jump into the threads concepts. Okay. Give me a second. Okay. So what are maps? Okay. So it is nothing but an object that stores keys and values. Okay. They associate keys with values. That is what our map means. Okay. It contains a set of key and value pairs. Okay. And both keys and values are objects here because we are from the beginning, right? From collection framework, we are discussing only about the objects. Okay. Here both keys and values both are objects, any kind of object for that matter. Okay. But there is a condition constraint, that is keys must be unique. Okay. Keys must be unique, but values can be duplicate values. Okay. It can different keys. Okay. Different keys can have same values. That is, values can be we can have duplicate values, but keys must be unique. Okay. Also, some maps can accept null values and null keys and values, but others might not accept. Okay. And couple of important points to think and remember about maps is they don't implement iterable interface. Okay. They don't implement iterable interface. That means you cannot use for each for loop for iterating through your map objects. Okay. Also, since it does not implement iterable interface, you don't have iterator method itself. Okay, iterator method belongs to your iterable interface. So collection extends iterable interface. That's why all the objects have the iterator method, which you can use it for any of the objects that comes under your collection framework. But since maps does not extend from iterable interface, we cannot use iterator for looping through the objects. Okay, within a particular map. Okay, so but this is not a limitation. What we can do is, like, we can get there are methods which gives you a collection view of your maps. Collection view means you can convert a particular map into a set. Okay, or to some other data structure, and then you can use the iterator to iterate through the elements within a particular map object. Okay. So let us see all those things, how those things are done with some examples. Before that, we will first discuss about interfaces that form the basis of the maps, and then we'll discuss about abstract and concrete classes, and then we'll dive into the examples. Okay. Okay. So let us discuss about interfaces first. We have a few interfaces with respect to maps. These are the interfaces. One is map. So map is at the root of your maps. Okay, like a collection for collection framework, map is at that level. Okay, it maps unique keys and values. Okay, so key and value pair is unique because we have unique. Okay, even if you have duplicate values, you'll have unique keys. Okay, so each object in your map is an object of type map dot entry. Okay, which is nothing but entry is a member of map interface itself or map class itself. Okay, this entry map.entry map.entry represents one particular key value pair. Okay, one particular key value pair within your map object. Okay, that means if you have a map, for that matter, like if you compare this map with any of the collection uh, objects, for example, your set object, set can have one particular type of objects that you pass as a type parameter when creating the object, right? For example, take you are creating a set of strings. Okay, so each and every object that you are going to store in the set object is string object, right? Similarly, when you create a map object, each and every object will be of type map.entry. Okay, so this map.entry is nothing but one key value pair that represents one key value pair within your map object. Okay, this map.entry can be anything. Okay, we'll discuss about that later. Okay, then we have a sorted map interface similar to our sorted set, sorted set. Okay, and I think it is sorted set only. Okay, so it extends the map interface. Okay, and whatever the objects that you store in sorted map, they are sorted in ascending order based on your keys. Okay, based on your keys, the ascending order is maintained. That again depends on the parameter that we pass while creating the sorted map object. Okay, that is comparator. So you can use comparator to change the order in which you are going to sort the elements within a particular map. Okay, the same thing can be applied to your sets also. Okay, and we have a navigable map which extends a sorted map to handle retrieval and retrieval of entries based on closest match searches. Okay, closest match searches. We'll discuss about that. I would request all of you to kind of like try more examples on navigable map, and one more is there in your navigable set, I guess, if I'm not wrong, or navigable list. Okay, so try those things and let me know if you have any questions with respect to those things. Okay. Okay. So let us move to the interface part. First, we'll discuss individual interfaces, related methods, and then move on to the classes, concrete classes. Okay. So as I discussed, it maps unique keys and values. By using keys, as we just discussed, keys are associated with values. Okay, keys must be unique. Keys are associated with values. Okay, given a key, you can get the value associated to that particular key. Okay, so you can retrieve a value associated to a particular key if you know the key. Okay, that is how you retrieve the values associated with the particular key. Okay, this is also a generic interface. So the declaration is like this. We pass two type parameters. K for type of keys. Type parameter for V is for type values. Type of values. Okay. So let us see the method. There are a bunch of methods for your map interface. Okay. So let us see. So obviously, like you can just connect these things with the collection interface methods. Okay, clear. Obviously, clears. It removes all key value pairs within a particular map on which you are invoking. Okay, contains key. This is similar to your contains method. So in collection, you are trying to compare. You are trying to verify whether a particular object exists in your collection or not. Here we are checking whether a particular key exists or not. Okay, we pass argument as key, and if it contains key, the invoking map contains key, it will return true, otherwise it will return false. Okay. Similarly, we have contains value. So that is similar to like checking whether you have key. Here we check whether we have particular value or not. Okay. And then we have another method that is entry set. So this is where we get the set or collection view from your maps. Okay. So you can get a collection view of your map and use your for each kind of for loop, new for loop, or your iterator method. to iterate through or cycle through or loop through all the objects that are there in your map. Okay, so entry set will return a set object. Okay, this is our entry set. Okay, so that will return a set object. Please stop me whenever you have any questions. Okay, so here this is the method. So it returns a set object which contains an object, right? It takes a particular type parameter. Okay, it takes a type parameter. Here the type that we are passing is map.entry type. Okay, since map.entry is also a generic type, we have to pass the types for key and types for your values. Okay, so entry set will return a set which contains objects of type map.entry. Okay, map.entry. So in order to get a single key out of your map, you can use get method. I mean the value associated with this particular key. Hash code, you can get it by using hash code method. Equals method, it compares the invoking object or invoking map entry with the object that you pass as argument here. Okay, so sorry. And then you have a method similar to our collection. Is empty, it will return true or false. If the collection or if the map is empty, it will return true, otherwise it will return false. Okay, so here we can use key set method, which will return a set object that contains keys. Okay, only keys. We are talking only about keys here. The entry set will give you a map.entry object set that contains map.entry objects. Key set will give you a set which contains only keys. Okay, and then we have this one, values. So values will give you only collection view of your values, only values. Okay, you can use any type. Here we have to use only set because keys must be unique. Okay, that is why you can use set here. We have used set here, but values we can have duplicate values. That is why we can use any of the things like your list. Okay, your if you have unique values, you can go for set as well and queues. Okay, and in order to add a key value pair or entry set into a particular map, you can use put method instead of add all those things. You have put methods and get methods. Okay, so put all is similar to your add all. Remove, we had remove as well. Size, it returns the number of elements or map.entries inside your particular map. Okay. Okay, so maps revolve around two basic functionalities, that is put and get. Put is to add key value pairs. We pass this is your put method. Okay, so key value pair into a map, and get is to retrieve value associated with a specific key. That is what we just discussed in the slide. Yeah. Okay, this is the get method that I was talking about. Okay, this is the get method. Okay, so next we move on to sorted map that extends map. Entries are sorted in ascending order of keys. Okay, keys are ordered in ascending order, and that is how the sorting is done with respect to your sorted map. Okay, so this is also generic interface as most of the classes in your util package. Okay, are in collection framework plus your maps. Okay, so methods associated with this is your comparator. This returns a comparator associated with particular map. These are all methods related to your sorted map. Okay, the map interface defines its own method. Sorted map extends your map interface and adds few other methods like comparator. It returns a comparator for your particular map. You can get first key within your map. Okay, so all your objects in your sorted map are sorted in ascending order, right? Based on your key. Okay, so first key you can get it by using your first key method. Okay, first key method, and then you can get similar to our sorted set and sorted list. Did we have sorted list? I don't remember exactly. Okay, so you think about that. Okay, you have I think in the sorted set you had head set and tail set. Similar to those things, you have head map and your tail map. Okay, so you can specify the end from top to till which object you need. You can specify, but from first entry to last -1. Okay, that those are the entries that you'll get it as sorted map in this case. Okay, last key you can get it using last key method. Okay, submap, the sub map in between you can get it using submap. You can specify start and end, which gives you start from the starting object till your end -1 objects. Okay, map entries. Okay, tail map obviously it gives the from where you specify, that is from start to till end you'll get those objects. Okay, then we move on to navigable map interface, which extends a sorted map and defines some of its own methods. Okay, this is also generic, and this is how it is declared. Okay, so let's know if you have any questions. You can stop me in between and you can ask your questions. Okay. So these are all some of the methods which I don't want to go in detail. Hierarchy, the largest key with key greater than obj, whatever the object that you pass. Okay. So last entry is there, lower entry is there, lower key, navigable key set that is similar to your key set, and then pole first entry, pole last entry. Okay, it returns first entry and last entry, removing in the process, removing the entry in the process. Okay, and then we have few more methods, submap and tail map. Okay, you can just refer to these things API and try to write some programs based on these things. Okay, this is I'm asking you to do this because if you have any questions when you are trying to do these things, other things I have covered in the sessions. When you try to do these things, you might get a lot of doubts. Come back to me and I'll try to clarify your doubts. Okay. Okay. So next to move on to map.entry interface. This represents individual entry in your map. That is key value pair. Okay. Each individual key value pair. For example, if you consider you have set of objects within your map. Consider this is your map. Okay. So each, say for example, you have each object in each row. Okay. So this is object 1, object 2, object 3, object 4, object 5 and all. Okay. So each object should be of type map.entry. Map.entry, and this is a generic interface. You can pass 2 parameters, key and value. So that is what each object will be of type map.entry, and you can specify. For example, if you want to store keys in string and values as string, you can specify string and string, and you can store those entries. Okay. Whenever you try to add a key value pair inside a map, that will be converted into your map.entry object and then stored in your map object. Okay. Let's move on. So what are the methods available in your map.entry? You can get map.entry from your map, and then you can use one of these methods to get the values. To get a key, you can use get key. To get a value, you can use get value, hash code, and for a particular key, if you want to set a value, for a particular key means you are trying to invoke this method on a map.entry object itself. So you know what is the key, okay? Key and value that represents one particular key value pair. So for that key, if you want to set the value, if you want to change the value, you can use set value method. Okay. So Boolean obviously it will check whether the invoking map.entry object is equal to the argument that is passed here. Okay. So I'm going a little fast because we have discussed enough of methods in our collection package previously. Okay. So anywhere or any time if you get doubts, please let me know. I'll stop there and I'll try to clarify your doubts. Okay. Okay. So let's move on to map classes. Excuse me. Similar to our abstract collection. Okay. Similar to our abstract collection, we have abstract map. Okay. So which implements most of map interface methods. So then we have enum map, which extends abstract map to work with enum keys, enumerator keys. Okay, you know what are enums, okay, right? So enum keys, if you have a map with the enum keys, you can use enum map. Okay, hash map is similar to our hash set, which extends abstract map and use hash table. Okay, tree map is similar to our tree set, which extends hash map, and it sorts. It is your this one, what is it? Sorted map. Okay, it keeps all the elements in sorted order. Okay, weak hash map, linked hash map, and identity hash map are other classes which extends abstract map, hash map, and abstract map respectively. Okay. So weak hash map is something like you have keys, right? So those keys, if you what happens is when a garbage collection runs, it sees whether keys are associated with some objects, okay, that is values. If it does not find any respect association between key values, the particular map object will be garbage collected. Okay. Okay. Let us see some of the examples. Please try to more examples on these things, and let me know if you have any questions or if you need any clarification on any of the topics. Okay. So let us start with the concrete classes. First, we will start with the hash map. Okay, it extends abstract map, implements map interface. Okay, so this is used it has like get and put methods with constant time. I missed time here. Constant time for large sets. Okay, for large sets, millions and millions of rows you might have in your database, which you want to kind of like map it and store it in your maps, right? And you want for if you want to add million number of objects in particular map, which has which should be associated with keys and values, you can go for this particular class, that is hash map. Okay, constructor, this is also generic class with this declaration. Constructors are default constructor. You can pass a map object itself to initialize it. You can specify the capacity, initial capacity. By default, it is 16. Okay, when you when you create an object of map with the default constructor, the default capacity will be 16. Okay, and fill ratio, it determines when say for example it is a value that is between 0 and 1. Okay, so say for example if you specify 0.8, okay, here this is a float. If you specify 0.8, when this map is filled, when the percentage of map is 80%, if it is 80% full, it starts growing. Okay, that is what is your fill ratio. Okay, so next you have tree map class. So hash map, we discussed in our hash set, it won't guarantee the order of elements. Okay, the order in which you added, when you try to display or when you try to kind of like read those objects which you have stored in hash map, that will not be in the same order in which you have added into a particular map. It can't guarantee. Okay, So tree map we have, it extends abstract map and implements navigable map, and it provides, it stores key value pairs in sorted order and rapid retrieval. Okay, if you want to retrieve, if you want to store all the objects in sorted order, and if you want to retrieve them in fast or quickly, you can use this particular map, tree map. Okay, and constructors are similar to your hash map, but we have one particular thing, comparator, because we can pass a comparator to change the order in which it sorts your objects. You can see a simple example how to create one particular user-defined comparator, and then try to kind of change the order in which the tree map stores its or sorts its objects. Okay, and when we try to print, we will come to know. It takes a sorted map. So these are the different constructors. You can just refer to those things. Okay. So we have another map, that is your linked hash map. So hash map won't guarantee you the insertion order, but linked hash map, it will maintain the insertion order. Okay, so the way the order in which you have inserted the key value pairs, they will be maintained within your hash linked map object. Okay, these are the constructors. This is also generic class. You pass type parameter for the key, type parameter for your values. Okay, so let us see a couple of examples with respect to your tree maps. Okay, let us close these things. So I have only one file, only one Java file which handles all these things. Okay, so we have initially I have created a hash map which takes strings and string as parameter. Okay, keys are also strings and values are also strings. Okay, so this was not needed actually. Okay, let it be there. So we are adding we cannot use add methods because it does not extend collection interface. So that is why we can use put. We have alternative method, that is put. Okay, I'm putting key and value. So 5 map.entries I have included in your hash map. That is your HM. Okay, I'm trying to print it here. So print similar to how we used to print in for collection objects, right? It prints in similar way. Okay. So then what I have done is I have created a linked hash map, and I try to add similar objects to see whether it maintains the order in which they are added. Okay, to see whether they are maintained in the same order. Okay, we can get that thing here by displaying the hash map itself. Okay, then I have created or I got. We can use entry set to get a collection view of your map. Okay, it returns a set object of type map.entry. So this should be of type string and string, because whatever the objects that we have in your map is of type string and string. So each object will be of type map.entry. So map.entry takes key and value. So here whatever we have specified is both strings. Key is also of type string and value is also of type string. That is why map should also be like whatever you specify here, right? That should also be of type string and string. Okay, key should be string, value should also be string. Okay, so once you get a set view of your map object, you can use map. For each loop to iterate through each object. So as we know, each object is a map.entry object, and map.entry object will have key as well as value associated with it, one pair, right? So you can use get key and get value to retrieve key and value associated with that particular map.entry object. Please let me know if you have any questions. Okay, so I will clarify those things. Okay. Once that is done, what am I doing here? I'm using clear method on linked hash map to clear the entire thing. Okay, whatever the map entries that are there in your linked hash map, I am clearing those. When you try to print the size after clearing, it obviously will show 0. Okay, so the elements when you try to print it, nothing will be there. Okay, and then we have hash map. This will give key set will give you a set of keys that are in your hash map. Okay, so we can iterate through these keys by using for each loop, and I have created one particular tree map which is initialized with HM. That is your this particular hash map. Okay, key 1, value 1, and all. And it obviously when you try to display the values, it will store all the values in sorted order, right? So if you want to add, I mean, I've added a couple of more objects so to see whether it is sorting in right order, that is in ascending order. Okay, so I'm trying to get a key set of whatever the values that are there in your tree map, and I'm trying to print the values here. That's it. Okay, tree map dot get of key. So I have used key get method here instead of get key get value methods. Okay, because this is a set not map. Okay, by passing key to get method, we can get the value. Okay, so that is what is I have done in this particular program. It's very simple. Let us run this program and see what exactly is happening. Okay, hash map entries. So as we discussed, it won't guarantee the order insertion order. Okay, so it is displaying this way. Okay, it has not maintained its insertion order. Okay, 4, 3, 5, 2, and 1. Okay, and the linked hash map. If you see the entry, I have added key 1 to key 5. Okay, so it is maintaining your insertion order. First, I have added the key 1, next key 2, next key 3, 4, and 5. Okay, it has maintained its insertion order. So next, what am I doing? I am getting the set view of your hash map, and I'm trying to print that using get key and get value on your map.entry object. So that is what is being done here. Hash map. Okay, this is your hash map. And then I've cleared here. So I think you should be able to. What is in reverse order? Kavita is asking some question. So let me take up that question. Okay. Yeah, Kavita is asking why is it in reverse order? Which one is in reverse order, Kavita? Let me check the output. You're talking about these things, right? This is in reverse order, or this one is in reverse order. So I'll explain that one. Okay. No, here this is not in reverse order. You can see that key 4, key 3, key 5, key 2, and key 1 are there. Okay, here also it is not in reverse order. We will see how to display it in reverse order also. Okay, so after deleting the values from your linked hash map, nothing is displayed and the size is 0. Obviously, you have cleared everything in that particular hash map. Okay, and then you got the key set from your hash map and you are trying to display it. So this is what you are displaying using your for each for loop. Okay, tree map. Okay, so Kavita has some questions, so let us take it up. Yeah, Kavita, go ahead, please.
Yeah, I mean, first when we assign the hash map, we are putting the values as value 1, value 2. I mean, in the if you see the
That
code.
order. Okay.
Yeah.
Yeah. Okay. Sorry. Yeah. Go ahead.
Yes. So we are putting it like for key 1, it is value 1 in that way, right? So the output also should be when we retrieve the key, it should come key 1 first, key 2 according. That's what I mean, I am expecting.
So for your hash map you are talking?
Yeah, for hash map, I mean it will, yeah, hash
No,
map,
for
linked hash map also, both.
yeah, okay. So for hash map, it won't maintain your insertion order. That is what I was mentioning, right? So hash map
Oh,
will not guarantee the insertion order. It can, when you try to retrieve it, you can retrieve it in any order. I mean, like whatever the order it gives you. Okay, that is what hash map does. But linked hash map, obviously, it is similar to your linked list or linked set. Okay, it
yeah.
maintains, this particular object maintains insertion order. That is what when we try to print that value, right? Whatever the values that you have inserted in linked hash map. Okay, so here I am first entering key 1, key 2, key 3, and key 4. That key 5. That is why it is maintaining its insertion order. Okay, that is your linked hash map, not your hash map. But hash map won't guarantee
Okay,
you that
because
it will
I
store
am
it in
seeing
insertion order.
whatever is down. Okay, I saw the down one, so I thought
Okay, so
the output.
we can check. Yeah, yeah. Hold on. Oh,
Get
hold on for a second.
get key.
Okay, so this one. Are we talking about this one?
Yeah, yeah.
Okay, so here we are. So entry set we are getting from your hash map, not from your linked hash map. Hash map. Okay, this is your hash map. HM is our hash map. In whichever the order HM gives to this particular set, right? That is how it is. It will be displayed. Are you getting?
Okay. Yeah, yeah, yeah.
So
Because I
whatever.
thought
Yeah.
both the linked list is also the same. So I didn't see this
Okay.
output, so I thought in that.
Okay. Okay. Let us try to do this one. Okay. HM size view. Okay. Let us try to do this for your linked. I hope that is the one which okay. Hash map, that is the one. Okay. So set view one. We will use the set view one here, and this is the entry. So we can try to print it. Okay. Size of LL hash map. Okay. Let us see how it displays. Let us try to differentiate between that one. Okay, linked hash map key and value. Okay, so here is your
Yeah.
hash map. Okay, so it has 5 elements. So here is your linked hash map. So you can see the difference, right? It is in
Yeah.
ascending order. Okay,
Yeah.
so we have cleared it. So all other things should be obvious. You get a key set. Obviously, when you try to get a key set on your linked hash map, you'll get a sorted keys. But with respect to hash map, only hash map, you will not get the sorted order, right? Not sorted order, sorry. It is like insertion
It
order.
is an insertion.
Okay. Yeah, it is insertion order. So if you try to change this, okay, so if you try to change this here and try to put this one here, yeah, that will make sense. Otherwise, I'll get confused like it is the sorting like that. Okay. So now you can check. Okay. So here is your hash map, but you can easily make out that here itself 4, 1, 2, 5, and 3. 4, 1, 2, 5, and 3. Right. So when you try to print that values, it will maintain the insertion order itself. 4, 1, 2, 5, 3. The same order you can expect it while you are printing it. Okay. And we have tree map. Where is tree map? Yeah, here is the tree map. I have initialized with the HM. That is our these values. So it will sort it in order. Okay. Let us try to comment out these two things. Put these two things to show that it will sort it in right order. Okay. But when you try to iterate through, it will it has sorted in ascending order itself. Ascending order of your keys. So key 1, 2, 3, 4, 5. It has sorted it. Okay. So we can't like we have added the values like this only, right, in our hash map. So we don't know whether that has sorted or not, right? So let us uncomment these things and see whether when we add extra objects to it, whether it sorts or not. Okay, so you can clearly see it has sorted, and when we try to retrieve them, it will give you in sorted order. Okay. Okay. So that is what your hash map, linked hash map, and tree set. Sorry, tree map. Okay. So all those things I have tried to cover in one particular program. So I think most of the methods that we have in map interface I have shown in this particular program. Okay. You can try different things also. Okay. So let us move on. Okay. So we have seen in a couple of objects, right? Constructors. We have seen we have passed comparator here. Okay. So what does this object does? So by default, this maps and so tree map and tree set, right? They keep their objects in sorted order. By default, they use a comparator which is defined to define for what is called as the natural order. Natural order. Okay, that means your 1 comes before your 2, 2 comes before 3, 10 comes or 9 comes before your 10, or A comes before your B. That is your natural order. Okay, natural order is, that is what you call it as natural order. So default comparators are written in such a way that that particular part is taken care. The sorting is done in natural order. Natural order. Okay. If at all you want to, that is done using your default comparator that is provided by Java. But if you want to change the order, or if you want to change the sort order itself, you can define your own comparator. Okay, you can define your own comparator and pass as argument to the particular object which stores, that is tree map in our case, or tree set or tree map. Okay, so that will take whatever the comparator that you pass and sort it based on your logic, whatever the logic you have provided in your comparator. Comparator is nothing but an object which takes, which defines one particular method, that is your compare method, and it compares both the, it takes 2 arguments, okay, 2 parameters it takes of type object, and it compares the 2 objects, okay, the 2 objects it compares, and that is the result of the compare method will be used to sort the objects accordingly in your tree map or in your tree set. Okay, so let us see an example how to change, write your own comparator. Okay, so here we have comparator. It's an interface. It is an interface. Okay, it takes, you have to pass, it is also generic type, so you have to pass the type of the object that you are trying to compare. Okay, so you know that tree set and tree map store the elements in sorted order. That is done using comparator. Okay, so it stores in natural order as we just discussed. So if you want to change the order in which the sorting is done, you can use, you can write your own comparator and pass that as the argument to the constructor, which takes argument as comparator argument, which takes comparator argument. Okay, and then it defines 2 methods. The main method that we will be doing is like compare method. Okay, as you can see, it takes 2 objects of same type that you pass here, object 1 and object 2, and it compares. So we know, we remember, like there is a method called compare 2, right? It returns an integer. Similarly, compare also returns an integer based on the value, whether it can be 0, negative, 0, or positive value. You can say which object is which object comes before the other object. Okay, in natural order. Okay, so similarly, you can write a logic similar to that one for this compare method, or if you want to write some other method also, you can write that as well. So that particular comparator will be used when you pass that user defined comparator to your tree map or tree set. Okay, it also defines equals method. Okay, so we know what does the equal does. Okay, it compares 2 objects for equality. Okay, let us see an example, then that will make sense. So comparator example is there. You have a comparator. What you have to do is, this is your comparator object. Okay, this is your comparator. You can change it to my comparator. My comparator, and here you can have, okay, my comparator. So what is it doing is, what happened? Okay, and now it is done. Okay, so you have to implement one method, that is the compare method. So you can, so it takes two objects, right? So we have we are passing a type parameter as string. Okay, you are comparing two objects of type string because we are passing type parameter as string. So what does this do? Usually, how does your compare to method compares? Say for example, you have o1 dot, that is object 1, compare to compare to, excuse me about my handwriting, it's too difficult to write, but trying my level best. Okay, okay, oh man, I myself am feeling ashamed of this handwriting. Okay, so we are trying to compare object 1 with object 2, right? If object 1 is greater than object 2 or comes after object 2, the result will be positive. If both are equal, the result will be 0. Negative, this comes before this one, negative. Okay. Here, what are we trying to do? We are not trying to compare object 1 with object 2. We are trying to compare object 2 with object 1. That is, we are reversing the order itself, right? So let me know if you have any questions. Did you understand this particular statement? Did you all understand this particular statement? Let me know, because we are reversing the order of comparison. So here what is happening? Usually what we do, O1, it usually compares object 1 with object 2, and it returns an integer. If it is positive, if it is 0, both are equal. O1 and O2 are equal. That is, object 1 and object 2 are equal. If it is negative value, object 1 comes before object 2. So object 1 is your, say for example, A, and object 2 is your B. So object 1, if it is negative, A, object 1 is A and object 2 is B. Okay, for example I am telling, okay. But what are we trying to do now here? So we are trying to compare B with A. Okay, the result will be totally in opposite direction. Say for opposite result, whatever you are trying to do it. O1 compared to O2 is exactly opposite to O2 compared to O1. Okay, that is why we are trying to, what it actually does is it tries to sort the objects in your map or whichever the tree object that you are trying to use it. It reverses the order in which it sorts the object within it. Okay, so let us try that one. So I have created one particular tree set. Okay, so I just taken, you can use it with your map also. Okay, so you can use it with your map, a tree map or a tree set. I have used a tree set here. So I am passing, it will store only your string objects. So I have stored it in this order. Okay, A, B, 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 C, and C. Okay, when you try to print it, you'll see that ABC in uppercase and then ABC in lowercase. It will try to print it in that order. But when you try to pass this comparator, so it reverses the order exactly. Whatever you see in this particular result, here it will be exactly opposite. Okay, that is what this particular comparator does. If you want to change the order itself, or if you don't want in ascending order, or if you don't want in reverse order, if you want any other order in which you want to do it, right, you can try that as well. Okay, you can provide that logic based on your whatever the logic that you write in your compare method. Okay, so but remember there are only three possibilities, that is the 0, a positive number and negative number. Okay, so if you see here, initially whatever it sorted in ascending order using default comparator. So A, B, C, that is uppercase letters comes before lowercase letters. That is why it is sorted in this particular order. And when we passed the user-defined comparator, which sorts the elements in reverse order, when you pass it as argument to this particular tree set, okay, this is sorted in reverse order. So in this order, it has sorted the elements, okay, in reverse order. That is what this particular comparator does, okay. So comparator, we have implemented compare method. So who calls that compare method while sorting? Who does the sorting here? Tree set itself does sorting, right? So tree set itself will call compare method internally while sorting it. Okay, similar to how we filtered the objects using except method in file name filter, right? Similar to that one, tree set itself will call compare method internally while sorting the objects based on the comparator that you passed. Okay, that you can verify using print line statement. Okay, when you run this program, so you'll be able to see these things. Okay, tree set elements. After this, we have passed comparator. Okay, so let us see this also. So let's put some statements in. So we don't have a default constructor. So default constructor, once the object is created, while sorting it, while adding the element itself, it calls your compare method and sorts it. Okay, you can see this, the output. Internally, that is called before sorting, and once you try to print it, the sorted objects, you'll get this result. Okay, hope all these things make sense. Yeah, in descending order, Kavita is telling, yeah, in reverse order, that is your descending order. Okay, yeah, Kavita, correct. So that is your maps. Okay, and then we have something called as collection algorithms and arrays class. Okay, so these two things define a few methods which are static methods which you can call on any of the collection objects and map objects. Okay, say for example you have this is collection algorithms. All the algorithms are defined. Let me open that particular class. Okay. I'm afraid to go to 8, so that's why I always refer to 7 because lot many features have changed. I think in 8. I think functional programming in Java is introduced. That is, Lambda is introduced in 8 or in 7. Okay, so that's telling 8. So we have a class called collections. Okay, remember the difference. Collections with the S attached, that is plural, is your class. Okay, but collection is your interface. Okay, collection is your interface, but collections is the method. I mean the class. Okay, it defines n number of static methods. Okay, it defines n number of static methods. So many methods are there. Add all. So whatever you can refer to these things. Okay, I will not go through these things. Some basic methods you will see, and you can refer to these things: empty list iterator, all those things. Okay, entry set, empty map, all these things. If you see all these things, right, these are all static methods. Okay, so go to this list and try to do some programs. If you have any doubts, okay, I keep repeating this one. If you have any, if you need any clarifications on any of these things, okay, if you need any clarifications on any of these things, not only for collections class, okay, till whatever we have covered till now. So if you have any doubts, please let me know. I'll try to answer. So keep this email ID handy. That is Java training at gmail.com. Okay, intuition.javatraining@gmail.com. Okay, please shoot out an email. And very few people have started asking questions. Maybe 3-4 people. Okay, so not many people are asking. I am assuming like you all understood these things well. Whatever I have taught, you all understood well. Okay, that is why nobody is reaching out to me for any clarifications. Okay, so these are all the methods which are all static. You can directly call on collections class itself, collections.list, collections.max, collections.min. Okay, to get respective things. So reverse order, you can pass, you can get the comparator using your reverse order. Okay, you can use this particular, say you have a particular object and you want to kind of like sort it in reverse order. You can use this particular method. Okay, by passing as arguments to reverse order method, a collection, whatever the collection you want to sort it in reverse order. Okay, so let us close these things. Algorithm. Okay, algorithm test. So what are we doing here? We are trying to create a linked list object. I've added a couple of few objects. Okay, I'm getting one particular comparator. Okay, from collections. So what does it do is it gives a comparator which sorts a particular collection in reverse order. Okay, this whatever the logic that we had written in previous class, previous example, right? That is my comparator. Similar logic, the comparator with similar logic would be returned to us. That particular comparator, we can use it to use it on any of the objects. Okay, we initially we got this particular reverse order comparator, and then we can call another method on collection to sort it. Sort what? Linked list, whatever we have created here, based on what? Based on the comparator that we got it. Okay, reverse order, in order to reverse the order in which the elements to be sorted. So remember, we have used the linked list here. Okay, we have not used like tree set, tree map or something like that. We have used linked list. It simply stores the objects, a group of objects in insertion order. It maintains the order in which we have added the elements. That is in this order: -8, 20, -20, and 8. But when you sort it, yeah, correct. When you sort it, that will be in reverse order. Okay, these elements will be sorted in reverse order, and then they will be kept. Okay, like this one, -20, or in natural order would be -20, -8, 8, and 20. Right? Is that correct? Okay. But reverse order means it will be in the reverse order. Yeah, Kavita has mentioned it. 20, 8, -8, and 20, -20. Sorry. Okay. So this is how that is sorted. Sort method takes an argument of comparator and then any collection object. Okay. When you try to print it here, it will print the objects in reverse order, whatever not in this order, in insertion order. Okay. Then you can shuffle it. Shuffle it like you can you just shuffle all the objects. So whatever the objects that you want to print after shuffle, that will be printed here. So you have a couple of methods like min and max, which will display what is the maximum value and what is the minimum value of these things within your linked list. Okay. This is what your output. Okay. So here it is sorted in reverse order: 28, -8, -20, and here it is shuffled Okay, it may not be like the insertion order. It can be in any order. Okay, let us try to run it one more time and see whether that is shuffled in different. Yeah, it's shuffled in different way, right? Okay, so this is also different. Okay, but minimum value and maximum value and this reverse order is remains the same. But whenever you shuffle it, the order changes. See here, the order is changing, right? So that is what your shuffle does. But please go through this API, and if you have any doubts, right, please let me know. We can discuss. I might not be knowing these methods properly. So when you ask questions, I'll go through those methods and I will try to get more information and try to answer. Okay. So that is why I request all of you to go through these methods, try to experiment with these methods, write some simple programs to check whether whatever they are trying to achieve with these methods are being achieved correctly or not. Okay. And let me know if you have any doubts. Then let's move on to the next one, that is our arrays class. Okay, so it is used, this also defines static methods which can be used with your arrays. Okay, lot of methods are there. Okay, as list, binary search. Okay, binary search you have for each array, each primitive type. Okay, byte, okay, char, double, float, and all these things. Okay, you can pass an argument array, and then whatever you want to do, you can do it. Like binary search, if you want to search for a particular value inside your array, you can search it using your binary search, and then copy of for a particular. I mean, you have a particular array, you are passing it, and then you want a copy of that particular array. You can use this particular copy of method, and copy of range. Obviously, it is like you specify from and to like indexes from where from which range you need. So this will copy your range. Equals, obviously it checks. If you want to add additional values to an array, so you remember, you know that these arrays are the fixed length arrays, right? If you want to add additional values to this, you can use this fill method. Okay, so that particular array will be automatically adjusted according to the elements, number of elements that you pass. Okay, so here, okay, so for each and every individual primary, I mean primitive data type, we have those values, and the sort. So we are primarily dealing with the arrays here, right? Primitive types only. Okay, most of the time, some are objects also. Okay, two string. So those are all the methods that are there in your arrays class, which are all static methods. You can directly call on your arrays class itself. Arrays dot copy of range. Okay. So this is an example. Okay. So what are we doing here? We have created one particular int array. Okay, some values we are trying to assign it. Okay, and then we have one static method which displays arrays. Okay, original array, after creating this array, we are trying to print it. It will print the array. Okay, we are trying to sort it. So it is natural ordering. So we are trying to add few more values to this particular array. Okay, and then we are trying to print it, and then again we will try to sort it. So that is what is being done in this program. Okay, please go through them, and you'll be able to understand it. These are all not complicated programs. Okay. So initially, what did we do? We tried to add a few methods, I mean, few values to this array. That is what this is. This is the order in which we have added those values. When we sort it, this is how it got sorted in ascending order. Okay. So we have not specified any comparator or something like that here. So we have added a few more values to it. 2, 3, and -1. Not added values, but we have changed some values, I guess. 2, 3, and -1. Where is -1? Okay, this is -1. And what it got changed? This value got changed to -1. Okay, so 2 and 3. Starting with 2 and 3. One object we are trying to change it with this one. Okay, so index 2 and 3. This is your 2. You move it to third. Whatever is there in that, you moved it to third. No, I think it replaced it. Okay. and then sort. After sorting, it displays this value. So after calling fill, this is what your array looks like, and after sorting it, this is what it looks like. Okay, please go through those that also, like your arrays and the collections. Okay, guess you might get some questions on these also, like collections and arrays classes. Okay, and one more last topic before we move to next one. That is legacy classes and interfaces. Okay, before the collection framework and generics, all those things were introduced, there were legacy classes and interfaces for iterating through your this one. What is that? Your collection of objects. Collections of objects are not the kind of like how we could see all these things, like we have a collection interface at the top, and then you have collection interfaces which extends collection interface itself. Okay, list, queues, and your sets. Okay, and then you have abstract classes and classes. For map, you have map interface, and then other interfaces like sorted map and your which extends your sorted map as well, like tree map, hash map, all those things. Okay, so all those things were not there. Okay, that time what we had enumeration instead of iterator to enumerate through each object, look through each object that are there in your one of these objects. Okay, that is your vector. These are all classes: vector, stack, dictionary, hash table, and properties. This dictionary, hash table, and properties are kind of like your maps. It stores key and value pairs. Okay, dictionary, hash table, and properties. So these are like your list and sets. Okay, vector is your similar to your array list. Okay, stack is your as you know, like stack is your last or first in. Okay, you stack a set of objects, and when you are retrieving it, you retrieve from the top, whichever is kept last, you retrieve that one first. Last in, first out. That is what your stack behavior. That is what is done here. Please refer to these things also, including arrays and collections and whatever we discussed in our previous session. Okay. So if you have any doubts, please let me know. We can discuss those things. Okay. So that concludes this particular session. Let me know if you have any questions. Otherwise, we can wind up this class call. And I need one more class for Utils, and probably I'll be able to complete that in one class, and then one class for your threads, concurrency things. Okay. So I need two classes. Probably we will have it on Monday and Tuesday. On Tuesday, I have one meeting at 9 o'clock in the evening, 9 to 11. Okay. So probably we might end up winding up the session a bit early, from 8 to 8:45 or something like that. So if we are not able to cover threads on that particular topic, we will cover it in next class, that is on Wednesday. So Wednesday will be our cutoff for core Java. Okay. So please let me know if you have any questions. Otherwise, you have option of asking questions now, or you can send out an email to intuition.javatraining@gmail.com. Okay. So it is your choice. No, Hugh, there won't be any weekend classes. I just want to kind of like need some time. To be frank, I am with my family now. I just want to spend some time with my family. That is why. Okay. I don't want to take classes this weekend. Okay. Yeah, Kavita has one question. So what is that, Kavita? Properties. Yeah, I told you, right? Properties is a class which is similar to your key value pairs. You can store key and value pairs, but I want all of you to read, and I kind of like I wanted to make this thing like this one. What is that? I want some of you to take one of these topics. Okay, like say for example, you can take one topic like enumeration. Someone can take vector, someone can take stack, someone can take dictionary, hash table, and properties. So in our next class, or we can spend one class for all of you. You can just tell me which topic you want to take it and cue that presentation. Okay, you can take that particular topic and you can finish it in 5-10 minutes. You can finish that particular topic. Okay, take one of these topics, and or you can send me an email saying like I want this particular topic to present. You can take that topic, you can just explain it. What is that particular vector, stack or dictionary or hash table or properties? You can explain it. What are the methods available? How you can use those methods with an example. You may not have to spend too much of time. You can just spend 10 minutes at the max. Okay, you can spend 10 minutes, prepare 2-3 slides, and then you can present it. Okay, that way you'll also kind of like get some knowledge, and when you try examples, right, then you'll get a lot of doubts, and when you try to clarify those doubts, right, you'll get more knowledge. That's what my way of learning. So you can also try to do that one if it is suitable for you, or if it makes sense to you. Okay. Okay. So I think nobody has. I think no one has any questions. So let us wind up this session, and we'll meet on Monday. If I don't change the timings, it will be at 8:30. Okay, but Tuesday we will have at 8 o'clock. Okay, because I have meeting in the evening from 9 to 11. So that is why Tuesday we will have the session at 8 o'clock. But Monday we will have at 8:30. 8:30 to 10:30 we will have class. Okay, session. Okay. Thanks everyone. Thanks for attending this session. Enjoy your evening. Okay. Thank you.